Right. So in this geometry sum, the question said in words, O is the center of the circle. They always do that. They also said that PC is a tangent, because they have to say. You can't just assume. Alright? So you know that the tangent rules are there. So let's go through our rules again, because we have 9 rules. Plus, all the time that radii are the same lengths. Okay? And that interior angles. And if there are parallel lines, that there are corresponding angles going to all the rest of the stuff as well. Isosceles, triangles, what. But the 9 grade 11 ones are starting from the start. The line from the center perpendicular to a chord or bisected, is it there? Maybe I'm not going to use it, but is it there? It is there. Because it's 90 degrees, this will be the same. Okay, we'll see now if we are going to use it. But theorem 1 could possibly be there. Theorem 2. Angle at the center is twice the angle at the circumference. If you don't know your ammunition, you cannot fight the war. Angle at the center is twice the angle at the circumference. Is that one there?
Yes.
Where? Okay, we could do it, but that's actually theorem 3. It's fine. Remember that the angle in a semicircle is actually also still angle at the center twice the angle at the circumference. They did tell me that AB was a diameter, but you could see it anyway. But they also said it in words there. So that if it's a diameter, why is that 90? Angle in a semicircle. Definitely. 2 marks. 2. Because you know it's 90 and because you know the rule is angle in a semicircle. Right, definitely. Okay, so let's just go through the rules. I'm not reading what the question says yet. So how else could it look? Angle at the center is twice the angle at the circumference. You know the nice symmetrical one you can't miss? That's not there. But couldn't this maybe have been, if my finger's on here, go to the center, but it doesn't go from there to the circumference, so it's not there. Because it could be squished around. It could also be like pressed inside for that other one. It's not here. Are you with me? You've got to look for them all. Alright, so then we are through theorem 3. Theorem 4 is what? Bow tie. And bow tie says angles in the same circle. Segment. Is there a bow tie? Is this not a bow tie? No, why not? So many things wrong with it. Do you see a bow tie if I do draw it? But it's not. Because that's not on the circle circumference. And this one either. For a bow tie, it's got to be in. Please remember, it's not only that one, you could also have this one. Well, it doesn't look like a bow tie, but it could have been if I put it back together, where the little pieces are the same. And then for that reason, this might have been something to do with that, but it doesn't. Because this one is not even touching there, so it doesn't matter. Are you with me? I'm trying to get you to look for stuff. If you don't look for it, you won't see it. Then, what are the next 2? Cyclic quads. Cyclic quad? There's no cyclic quad, of which opposite angles are supplementary. Exterior angles equal to the opposite interior one. Not there. But then we've got the tangents. Definitely. Theorem 1. Oops, no. Radius is not drawn, so you don't draw stuff in except for theorem proofs. 4 of them, which you will get one always. Right? That's not there. Then the partiate.
No.
Why not? Because this child is dying. With the head's going right inside of his head. Are you with me? If it had gone there, then there were 2 tangents. Then you could look at that tangent. Partiate. 2 tangents from a point. But the last one, and in general, if there is a tangent, the tan chord theorem is there. Where would the tan chord be? C2 and A. Do you agree with him?
Yes.
Between the tangent and the chord, and it has to go all the way, chord being from side to side. So that's the angle between the tangent and the chord. Then you take your fingers to the chord and go where? Circumference, which would mean that one. Alright. And then in this sum, if I hadn't read anything else, I would have said, well, okay, I want to make them the same, so let's call them A. But I see they said in the second question, please make C2 X. So then you don't make it A, you make it X. So this is obviously going to be X and X. Are you with me? Right. We've gone through all 9 of our theorems. Looking at other stuff, I'm not seeing anything at the moment. Let's see what the question is. Please prove for me that OE and CA are parallel. When will lines be parallel? With corresponding or co-interior or alternate angles. We have corresponding angles because we've already seen a few things. That was given. Why did I do that in red? Because we know it is because of that. Angle in a semicircle. And if they are equal, then the lines are, I'm done. No marks because I haven't written anything. So where do I start? C1
is equal to
because? And you have 2 marks, which I could have written down 5 minutes ago and I would have had 2 marks. So that's why I say, in general, kids find geometry difficult because they don't practice enough. And you don't have to get full marks for all your geometry. If you only get for each sum, this one was worth 9 marks. If you can get 4 or 5 out of 9, then that's it. Then you do that. If you can't see everything, 4 or 5 out of 9, that's 50%. The stuff that you saw is definitely worth marks. For knowing that that x and that x is equal to each other is definitely worth another 2 marks. I've got 4 out of 9 already, just for seeing the basics. So you cannot say, I'm not doing the geometry. How stupid is that? Okay, so 90 degrees because of the semicircle. But then you guys saw that now we have corresponding angles are equal to each other. We don't have to say why they're equal, they're both 90. Did I have to say that D1 was 90 because it was given? No, you don't have to. I say it's both 90 because I'm making that connection and therefore the 2 lines are parallel because of corresponding angles that are equal to each other. Basically, it's the converse of corresponding angles. But if corresponding angles are equal, the lines are parallel. So that would be for the, not for this, because that was the question. The mark would be for that. 4 marks. Think about those 4 marks. Relatively, not that difficult. Okay, now they did say X for C2 and find 2 more angles. Well, I've already got 1. You guys already said that. A. Because it's not your own thing that you suck out of your thumb, the correct reasons, according to what I've given you that says correct, accepted reasons. 2 marks. Because the third one, where is the third one? Where can I get another one that's X? Has to be if they say I need another one. Okay, let me help you. Sums are scaffolded. So what? Now that you know,
O1
because of the parallel lines, the stuff that you've already got will help you with the next stuff. This one will help you with that, one will help you in general. So if you can't see it, go check. Why did they make me do this? So I can see that those lines are parallel and see that those are again corresponding angles. O1 and A are both corresponding angles. Because of those lines, OE and CA that I have proven parallel to each other. So it's basically just about the corresponding angle. They wouldn't have deducted marks from this because you've already proven it. Right. Let's get to the last question. They want angle P. And angle P's got nothing to do with the circle, but it's got to obviously get back to the circle. How would I get to angle P? It can't be any one of those other rules inside of a circle. Interior angles of a triangle for sure. In which triangle does that angle sit?
P.
P?
P.
I hear PO, I hear PB, I hear PA, and you're all right. Because it does sit in different ones. Which one's going to help you?
C.
PAC. So think bigger. You don't always have to go for a smaller one. You see it here, it's in that triangle. You have that X, but you're going to have to find that one. Then you can do some of the angles of a triangle, and you can do that. But if you look at, which other one did you say? PO. This one again. I've got O, but I don't have this one. I'll have to look for it again. And then I can find this one. It's not very difficult. But the one that's the more obvious one is PAC. Because you have A, it's X. You have C,
It's
90 plus X. So what's left? You're going to have to say 180 minus those other two added together. If you can just give me the answer, I'm happy. I'll give you the 2 marks. But rather show me what you've done so that you don't make mistakes. Because you're going to have to add X plus 90 plus X together and then subtract it from 180. So there's a little bit of problems with the negative there. And the reason, some of the angles of a triangle, which triangle? It's not necessary that you write it, but it's good that I can see where are you in the sum. So then what will happen here? 180, whichever way you write it, and then it's minus 90 and minus 2x. So that your answer would be 90 minus 2x. Okay, I'm done. So the answer and for the reason, whichever one you did. If you really wanted to go for another one, could you? What could I do for POE, this one? What would this thing be? Why?
Because
Corresponding angles, you see it? 90 plus x. And then you could have gone x, 90 plus x. It's the same thing that I've done there. You'll get to the same answer. Or we said this one. I've already got the x. What will be 2b? And somebody said, man, isn't this alternate angles, for instance, there? Say no. Because they're no parallel lines. Are you with me? Okay? How could you have done it then, for instance? Long way, short way. Okay, we could have said x, 90, so this will be, or let's do it easy. X and 90 will give me 90 plus x because of the exterior angle of a triangle is equal to the sum, so they'll still be. Okay, so whether you work with this triangle, 90 plus x and x, will still give you this one. If you work with this triangle, those two together will give you this one, and if you work with a big one, 90 plus x, still gives you this one. They all work out to the same thing, depending on which one you chose. The more obvious one to me was x was there, 90 plus x was there to get to sum. You do not need to show me any of this, but if you do it in your mind, you might have said plus or subtracted incorrectly there. So rather have more steps. Okay, so number 7 for next time.